So welcome back for part 2 of section, what is this? 9.1. We're working on displaying data. Someone gives us a horrible, ugly pile of numbers, and our goal is to make this be something that someone can look at and consume in a useful way. So we created a frequency distribution, whatever kind of frequency distribution you wanted to make, whether it's a standard frequency distribution with the frequencies in it, just these first two columns, or whether it's with relative frequencies or cumulative frequencies, but you have decided that this is insufficient, and now you want to make a picture out of this. You want to make a graph. And so the most common one to make is a frequency histogram. Now, a frequency histogram is a type of bar graph that represents that frequency distribution. The horizontal scale is quantitative and measures those data values. That's going to measure your classes. That's going to be your horizontal scale. And then the vertical scale measures the frequencies, and so that's going to be these guys right here. Now, the thing that makes this different from a bar graph is in a frequency histogram, or in a histogram in general, consecutive bars touch. So the bars are butted right up against each other. In a standard bar graph, you'd have your first bar, and then you'd have your second bar, and there would be space in between where those bars weren't touching. And that would be a standard bar graph. But in a histogram, the bars touch. So if I wanted to make a histogram for my frequency distribution, I would just do something like this. My horizontal axis is going to be my frequencies, but I'm going to add something. I'm going to change something about this horizontal axis, and I'm going to put a little dinky-dink right there. And that little break in the graph right there is what's going to tell me to not follow the scale from 0, but to follow the scale as it's been set. So I'm going to have my first bar, my second bar, my third bar, my fourth bar, my fifth bar, my sixth bar, and my seventh bar. And I'm going to choose to label my bars using the midpoints because I find that to be a little bit cleaner. So 172.5, 208.5, 244.5, 280.5, 316.5, 352.5, and 388.5. My highest frequency is a 7, so I'm going to come up here to the top, and I'm going to call that 8. If you're wondering why I chose 8 instead of 7, it's going to make doing this a little bit easier. 4, 2, 6, 1, 3, 5, and 7. And then I'll start drawing in my bars. My first bar, my first class with a midpoint of 172 has a frequency of 3. So that bar will be 3 units tall. So from here up to 3, over, and then back down. And then, of course, shaded so elegantly. My second bar has a height of 2. So I'm going to change colors so the bars stand out a little bit. There is no requirement that you do this. Your bars could all be the same color. And then my third bar is going to have a height of 5, so I'll go up to 5. Now I know what you're thinking. You're thinking, man, this is beautiful. How am I ever going to draw one this beautiful? The reality is you probably wouldn't draw these things by hand, would you? And then from 5 to 6, you'd most likely use some sort of computer software. Excel is really good at making graphs, and it makes a decent histogram. You do have to muck around with it because it doesn't want to make the bars touch, so you have to play with that. After 6 comes 7, that's our highest bar for the midpoint 316. And then back down to 4 for the next class. And then our last class, our 7th class, is a 3. Now I'm not quite done with this thing yet. I still have to label it. Down here, this is the money spent on drugs, on prescription medication out of pocket. Okay? Over here, I have my frequency, and then this is the dollars spent on meds out of pocket. Okay? So I gave my graph a title, I gave my axes labels, and I drew in my graph. I used up all the space that was given to me because I like to make big, giant graphs and use up all my space. Right? This is a frequency histogram. A frequency histogram is just a fancy bar chart, a histogram, where the horizontal axis represents your classes and the vertical axis represents your frequencies. What makes it different from a bar chart or a bar graph is the bars touch when it's a histogram. Right? I could also make something called a frequency polygon. Now what a frequency polygon is, and here's one down here for us, a frequency polygon is just that frequency histogram that we just made, but instead of drawing bars, they just put dots. So if you take a look, do you see how this dot right here represents the height of that first one? Label off that midpoint. And then this dot right here represents the second one. And then this dot right here is the third one. And then the fourth bar. And then the fifth bar. And then the sixth bar. And then the seventh bar. Now the one thing that is different about that frequency polygon is that it adds in these two. Right? Where did 136.5 come from? Well, that 136.5 there on that left-hand side is one class width below. And that 424 on the high side is one class width above, and you see it goes back down to 0 on both of those. Okay? Now the difference between a frequency polygon and a frequency histogram is not much. It's just which picture do you want to draw? Do you want your data to be represented using a bar graph? Then draw the histogram. Do you want your data to be represented using a bunch of dots and line segments? Then draw the frequency polygon. Neither is correct. They're both good ways to display data. It's just what do you want to show? Right? You could even go further and you could make a relative frequency histogram. Now a relative frequency histogram is just the same as a frequency histogram. We're just going to replace the vertical axis, and instead of having whole numbers over there for the count or the frequency, we're going to put those percents over there. And so now we could say that this first bar is 10%. And the second one is, I think it was 7% from the data set, but it looks like it's somewhere between 5 and 10, so 7 sounds good. This one's just north of 15%, so I think that was 17%, 20%, maybe 22, 23%. Looks like we're back down to about 13% or so, maybe 14%, and then that last one was 10% again. So if the story that you want to tell is you want to show the classes down here and their relative frequencies, you can do it that way too. It's just a different way to display the data. Now, if you're wondering about these numbers right here, those numbers right there are called the class boundaries. And what you'll notice is the class boundaries are 1/2 of 1 unit of measure below and above the class limits. So if I go back up here to the histogram, the class limits for the first class were $1.55 and $1.90. A half a unit below is that $1.54.5, and that half above is the 190.5. And so all of these are called the class boundaries, are the half below, half above, half below, half above for all of those intervals. That is just another way that one could represent that horizontal axis for the labels. You'll notice that they're still using the break in the scale here though, right? Now if you're wondering why, okay, here's the deal. Okay? Now think back to like college algebra when you first started graphing, right? If you said this is 1, then that has to be 2 because we have to keep that scale consistent. So if I say that this is 155, then this has to be, because it's twice as far, it has to be 310. And that wouldn't work for this, because if I label my first tick mark as 154.5. I can't label my next tick mark as 190.5 because this scale isn't consistent between those two. Okay? So I have to make sure that I do this correctly. I do it correctly by adding in that little break. Okay? That's our relative frequency histogram using class boundaries. All right? I'm going to stop this video here because the next section here, this measure of central tendency, changes gears completely. So we'll come back and make a third video for that.